These are the notes for Unit 5, Lesson 1. The topic is solutions. We've already studied solutions once this year, so pause the video for a minute and think back on what you've already learned about solutions. Do you remember that they are homogeneous mixtures that look the same throughout? Great. There's the essential question for this lesson is, what is a solution? And it says by the end of this lesson, you should be able to summarize the characteristics of a solution. So in this lesson, we'll go into greater detail about solutions and learn several new vocabulary words we can use to describe solutions. The picture here shows one example of a solution that's a solid at room temperature. This is a picture of people making glass, which is formed when soda ash, limestone, and sand are heated to become liquids and are mixed to form a solution. When they cool, then we have glass. So solutions can be all three states of matter. There are 3 learning targets in this lesson. The first is I can tell the difference between a solute and a solvent. The second is I can list ways to increase solubility. And the third is I can explain the 3 types of solutions: dilute, saturated, and supersaturated. There are 5 vocab words in this lesson. The words are solution, solute, solvent, concentration, and solubility. We started the lesson by talking about alloys. An alloy is a solution that is a solid at room temperature. One example is brass. If you play a brass instrument, like trumpet or tuba, your instrument is a combination of zinc and copper that were heated past their melting points, mixed together, and then when they cooled, you have the sort of yellowish metal that makes up your instrument. You might also have heard that word talking about cars. There are parts of cars that are made of metal alloys. Solutions, like I said, can be solids, liquids, or gases. Oftentimes the examples we use are just liquids, like that powdered drink mix dissolved in water. But today we'll talk about some examples that are also solids at room temperature and gases at room temperature. When we talk about solutions, there are 2 parts that make up a solution. The first is the solvent. That's the substance you have more of. The solvent has something else dissolved in it, and water is the most common solvent. So in that powdered drink mix example, the water that you dissolve your powder in is the solvent. If you look at cleaning products, a lot of them are made up of are solutions that have water as the solvent and then include some sort of a cleaning agent in a smaller concentration. The other part of a solution is called the solute. That's the substance you have less of. So it's dissolved in something else. In that powdered drink mix example, like Gatorade, the Gatorade powder you dissolve in water is the solute. We have a lot less powder than we do water. And then the statement at the bottom, I have in bold. I suggest that you make it bold or brightly colored, do something so it stands out in your notes. And then if you memorize this statement, you'll always be able to keep track of which is the solute and which is the solvent. So the statement that you need to remember is that you dissolve a solute into a solvent. When we talk about solutions, another way that we can describe them is by their concentration. Concentration is the amount of solute that's in the solution. I think we've all had some sort of beverage at one time that tasted gross because there just wasn't enough powdered drink mix or hot cocoa powder or whatever in it. Maybe it looked pale in color, it tasted kind of weak, not very flavorful. That sort of solution is called a dilute solution because there's a low concentration, there's not very much solute dissolved in the solvent. Then if you keep adding powder, you'll get to a point where no matter how much more you add and how long you stir, you can never get the solute to dissolve. That solution is called saturated. It might taste just right if it's a beverage that you're mixing. It might even taste too strong. It might be too sweet and very dark in color. And it's possible to create what we call a supersaturated solution. A supersaturated solution is one that's extra saturated. If you heat up the solvent, you can actually get more solute to dissolve in it than you would be able to at room temperature. And so that super, that prefix means extra. It's more saturated than it usually would be able to be, or more concentrated. So I recommend that students try an experiment. You can do this with salt at home. Start with a glass of room temperature water and add a little bit of a salt at a time, maybe half a teaspoon. Stir until it dissolves, then add another half teaspoon, stir it until it dissolves, and keep doing that until you add a bit of salt and you stir, and the salt just won't dissolve. It just sinks to the bottom and stays there. When you do that, you've created a saturated solution. And the reason no more salt will dissolve is that there's no more room for those salt molecules to move in between the water molecules. But then if you take that solution you've been making and you heat it up, maybe put it in the microwave and stir, you'll be able to get that extra salt that was on the bottom to dissolve in the water. So now it's super saturated. If you set it on the counter and let it cool, the salt should stay dissolved, but once you bump it and jostle it, then the salt will come out of solution. And I recommend using salt because it's so inexpensive. Lastly, there are some things we can do to affect the solubility of a substance, to affect its ability to dissolve, a solute's ability to dissolve in a solvent. The first thing is raising the temperature. When we raise the temperature of the solute or the solvent, solubility increases. That's why you heat up water to make Jell-O or to make hot chocolate. You heat it up first and then add the powder and it will dissolve faster. Air pressure, if you increase the air pressure of the substance, that will increase solubility. So if you look at a soda bottle or a can, you'll notice it says that the contents are under pressure. And when you open it, you hear that shh sound and you can feel the fizz on your face. What's actually happened is they raise the air pressure when they're bottling the soda so that they can get more carbon dioxide gas to dissolve in the syrup that they use to make the pop. And when you open the can or the bottle, then the air pressure changes to normal air pressure, whatever is around you, and a lot of the carbon dioxide comes out of solution then. So you hear it and you feel the fizz on your face. If you let it sit out at room temperature for a long period of time, eventually it's flat. It's lost all of the carbon dioxide that was in solution. A third thing you can do to increase solubility is stir the substance. That's why when you put powdered drink mix in a glass of water, you stir it. You don't just dump it in and drink it right away. That helps more of the solute, the drink mix, come in contact with more of the solvent, the water, and so it dissolves faster. And lastly, crushing the solute to increase the surface area will cause solubility to increase because, again, just like with stirring, more of the solute comes in contact with more of the solvent, so it dissolves faster. The last thing in your notes is a question. It asks you to give an example of a solute and a solvent. I've given several in this lesson. The carbon dioxide in soda syrup, powdered drink mix in water. We talked about glass at the beginning of the lesson. Any of those would be good examples of a solution, and then you just need to name the solute, what's the thing that is dissolved, and the solvent, the substance it's dissolved in. These are the notes for Module H, Unit 5, Lesson 1.